We present NEREx, an approach for named entity relationship exploration in multi-party conversations. Our tool is designed to support the exploration and analysis of multi-party conversations, and in particular to provide an overview and entry point for the analysis of unknown data. An example of multi-party conversations is political debates such as presidential debates. In these debates, candidates exchange opinions, arguments, and information with the goal to convince their listeners to support their campaigns and vote for them. Due to their long-lasting impact, political science researchers are especially interested in analyzing the opinions and arguments exchanged in these debates. To do so, they usually analyze their verbatim transcripts. However, extracting structured information from such transcripts is often very time-consuming. Our tool automatically extracts important entities from the text and classifies them into 10 different categories. These named entity categories are tailored for the analysis of conversational texts. We use these to abstract the content of conversations and provide a tight integration between close and distant reading views for the exploratory analysis. However, we're not only interested in extracting entities or the sequence of their appearance, but we're also interested in modeling the relationship between these entities to reconstruct the semantic structure of conversations. To do so, we can either rely on the linguistic information and grammatical structures of the text, or use the document structure to link together entities that appear within the same speaker turn. The grammatical modeling works well for highly edited texts, but not for verbatim conversational transcripts due to their often ungrammatical sentences. On the other hand, using document structure works well for text summarization, but constructs too broad relations for our purposes. Therefore, we introduced a distance-restricted entity relationship model. This model regards two entities to be related if they occur within a certain distance from each other in the same sentence. For example, for the sentence, I believe we can cut taxes by an additional 5 trillion, with a maximum distance of 5, the extracted entity pairs are cut taxes, cut 5 trillion, and taxes 5 trillion. Using this model, we can link together related entities in a graph structure, which we call the entity graph. This graph can give an overview over the complete conversation corpus. By varying the minimum entity pair frequency of shown relations, we can determine the level of detail of the overview. Additionally, to reduce graph clutter in the visualization, we introduce different node groupings. Synonym groups aggregate similar entities into one node. For example, all given names of a person. Relation nodes group all nodes related to only one other node. These are typically the leaf nodes of the graph. By right-clicking any relation group, the hidden nodes are shown. The number of edge stops of a relation group indicates the number of hidden nodes. Finally, we allow the users to manually edit any node in the graph. These edits include splitting and merging of nodes as well as rename and change of category. We make all nodes that have been manually edited visible to ensure the validity of the analysis. The 3 basic grouping types can be combined to form composite groupings. Our tool provides 6 different perspectives on the data. The entity graph displays the relation of all entity pairs in the dataset on different granularity levels. The text view is used for close reading and slow analytics, while the entity level view is designed for distant reading and entity level exploration. The speaker graph highlights the number of entity pairs different speakers have used in common. Beside these 4 views, the user can construct 2 additional views for a focused analysis. Concept graphs are created to analyze the relation of specific topics of interest. These focused graphs use various anchored layouts to support the user in exploring the tensions between different entity speakers and geolocations. Lastly, the temporal graph allows the review of a given topic over time. This graph is built incrementally based on the sequence of the entities in a conversation. We provide a rich set of interactions for the analysis and exploration of the data. These include search and filter, parameter adjustment, visual querying, as well as linking and brushing. Our tool is designed to support 5 different analytical tasks. These are data exploration, hypothesis generation, temporal analysis, hypothesis verification, and comparative analysis. We will now showcase the usage of our tool using the transcripts of the 2016 US presidential debates between Hillary Clinton and Donald Trump. These examples are based on observations from a pair analytics study with 3 domain experts. We'll start with the overall exploration of the datasets. The user switches from the text level view to the entity graph to get an overview. In the entity graph, the main topics of the debate become visible. For example, the topic taxes. The user also explores the most frequent entities. Then he switches to manually editing the nodes for the 2 speakers. First for Donald Trump, then for Hillary Clinton. The edited nodes are immediately displayed as manual nodes. He then notices the node Obama and continues exploring it. After selecting this node and its relation, he can switch to the entity level view to inspect where this relation appears in the text, and finds out that it was Trump interrupting 3 times with the question, "Is it Obama's fault?" The user becomes interested in looking at other instances where a person is mentioned followed by a negative emotion indicator, and uses the visual querying interface to search for that. He also becomes interested in looking for populist rhetoric and looks for instances of Trump's slogan, "Make America Great Again." After querying for that pattern, the user can explore all instances of similar statements to Trump's slogan, like "Make America Safe Again." The user is also interested in exploring the entity graph to find out which entity pairs are shared by whom. He first starts looking for pairs shared by the 2 candidates and explores the entity tax cuts. Afterwards, he looks for entities shared by Clinton and the moderator, and is interested in the pair avoid paying, which he explores in the entity level view. Next, we will discuss the analysis of the topic taxes. After finding a large cluster around the topic taxes in the entity graph, the user becomes interested in exploring this further. He therefore creates a concept container with the words related to that subject. And selects the 2 containers to create a concept graph. He chooses to use a speaker-anchored layout to explore the tension between speakers regarding that matter, and reviews the evolution of the topic throughout the debate in a temporal graph. During the animation, he observes multiple instances in which Clinton or the moderator attacked Trump for not releasing his tax returns. He also observes Trump responding that he is being under routine audit and switching the subject to talk about cutting taxes for companies. Next, he becomes interested in analyzing the topic War on Terror. To do so, he creates a concept container with the words related to that topic, and decides to use a location-anchored concept graph for exploration. The resulting graph shows all involved countries and the tension between them. In particular, it shows the association of entities to certain countries, for example Russia, related to strikes against Syria and deadly attacks. We have presented NEREx, a visualization framework designed for the analysis of verbatim conversation transcripts based on a distance-restricted model to extract named entity relationships. We provide 6 different views on the data, which are supported by various interaction techniques to tackle 5 analysis tasks. Finally, we demonstrated the capabilities of our tool with the analysis of the 2016 US presidential debates. Thank you for watching this video.